Hi friends, so we're going to start with acid, bases and salts. Acid, bases and salts have such a lot of importance in our day-to-day life. There are so many chemicals that you're knowingly or unknowingly using on a daily basis, and many of them are made out of acids, or many of them are made out of bases, or many of them are made of salts. Now what are all these? What is an acid? What is a base? What is a salt? And precisely that is what we are going to get an answer for in these series of lectures or presentations which I am going to take you through, where I am going to tell you what are these acids, what are these bases, what are these salts, what are their properties, what are their characteristics, what reacts with what and produces what, and how they react. Why something is called acid, why something is called base, why something is called salt. There are so many questions, right? And we are going to get answer for all of them. And we are also going to get also going to understand where acids are used, where bases are used, where salts are used, and what are the different kinds of acids, what are the different kinds of bases, what are the different kinds of salts. Oh, don't you think there's thousands of questions here? Yes, that's true, and that's the fun of this particular chapter, or this particular subject of acids, bases, and salts. So let us. I want all of you to look forward to it. Now, what I want to tell you is, before you go through this series of lectures on acid, bases, and salts, I would advise you to go through the elements and compounds lectures, because a lot of things which I'm going to explain here does have dependency on elements and compounds chapter, because things like what is an ion, what is a positive ion, what's a negative ion, what you call the cations, the anions, what do they mean, what is valency, is all some of the things which I assume that you know, because I'm going to take up those keywords and use it in this chapter. So if you don't understand them, you definitely have to refer back to the elements and compounds chapter. Alright, now the other advice that I have for you is, it's a good idea that you also go through your textbook and just read through the textbook. Even though you don't understand it completely, just read through it before you start attending these lectures. Alright, now I'm going to step into acids, bases, and salts. Let us start off with acid, bases, and salts. So, sorry. Alright, now what is an acid? Where does this name of acid come from? It actually in fact came from a Latin word called acidus. Acidus means sour, right? Sour. I'm sure that you would have told, this curd tastes sour, and probably you don't know why it is sour. Now you'll know that, right? But you say, well, this tastes sour, or this tamarind is tasting sour, or this lemon juice looks to be made of raw lemon and it tastes sour, right? Now, I'm sure that you have used this word called sour many times in your life, right? You have told ma, or maji, or mother, or amma, or whatever, based on where you are from. You have told, you know, this curd is tasting very sour. I'm not able to have this, right? Now, we are going to try to understand why that thing called sour happens to these substances, and why do they taste sour. And that is because of the acidus, or the acid, which is inside the substance, right? So the acids typically taste sour. So the sour taste of lemon and orange is actually because the lemon and orange inside has got what you call a citric acid, and citric acid is which gives that sour flavor or sour taste to the lime, or lime, lemon, orange. We call it in fact citrus fruits. I'm sure that people will say, you know, you should have citrus fruits because they're very rich in vitamin C, right? Now where is all that coming from? It is from citric acid, right? So the citrus fruits like lime, lemon, orange, all these actually has abundance of citric acid inside them, and it is that citric acid which gives that sour taste to that fruit. The other example is so now I'm just talking about places where there are natural acids, right? So there are several vegetables and fruits which you see around which has got natural acids, and citric acid is available naturally in the citrus fruits. The green apple, I'm not sure whether you've seen green apples, have you? So the green apples are apples which are green in color, and they're typically more sour than the red apples, right? And the reason why it's sour is because of the malic acid. The malic acid which is there inside the green apples give that sour taste. So always the green apples are more sour, and a lot of people like that. In fact, there are a lot of people in this world who like sour taste. They love it, they enjoy it, right? I'm not a great fan of sour, but still, what I want to tell you is there are several people who are fans of sour taste. All right, now the other example which I can tell is about the sting which you get from an ant or a bee. You know the honey bee. It can sting on you, right? And that gives you, I don't know, I'm sure that most of you would have experienced an ant sting. I have experienced it when I play around. When I was a kid and I used to run around the grounds and play football or cricket, and there will be ants out there, and they can give, it could be a black ant or a red ant which can give you a sting. And when it gives a sting, it's a horrible feeling, right? It irritates, you feel like itching there, and it's a very uncomfortable feeling. Now, why does you feel that? That is because when the ant is stinging, giving a sting, what it's doing is it's actually injecting a little bit of formic acid into your body. And the formic acid gives you the burning sensation. So for the ant, why does it have that formic acid? It's because it's a protection. If somebody is trying to attack it, it is going to inject the formic acid and give a bad feeling for the attacker. So it's basically a weapon that the ants have with them, right? But the explanation is done by the science. Oh, gentlemen, that sting is because of formic acid. Gentlemen and ladies, or guys and gals, as you call, right? So the reason why that sting and that burning sensation is coming to you is because of the formic acid which is injected by the ant or the bee onto your skin, and that gives the burning sensation. So you see so many acids that you talked about: citric acid, malic acid, formic acid, all existing in nature, as a part of fruits, as a part of sting from ant or whatever, right? Look at more examples like sour milk, right? Or curd. Sour milk is also called the buttermilk, right? I'm sure that you have heard about buttermilk, and in South India it's called moda, right? In Kerala, from where I'm coming from, it's called moda, and it's a sour tasted buttermilk which has got a lot of lactic acid inside it, right? And what about curds? Again, curds have a sour taste, and that's because of the lactic acid inside it, right? Now, how is the lactic acid produced in the curd from milk? Well, that's another chemical change, right? Which is mostly enabled by a bacterium called lactobacilli, right? So I think they have roles to play in the lactic acid being produced, and that's how the milk turns into curd, right? What's called the curding of milk. Then you have fruits like orange, amla. I'm sure that you know about amla. It's also called gooseberry in English, right? In English it's called gooseberry. This is what is gooseberry, right? And in India, different parts of India makes gooseberry pickles, right? It's very popular among the Indians. They love it because it's got a sour taste, and it also probably is put in salt and some chili and stuff like that. So slightly spicy, slightly soury, and it's like a mix of a lot of flavors. So it's a very popular thing, gooseberry pickles, or what you call the amla pickles, right? So the amla has got, let me just go back to the presentation. So the amla has actually has got citric acid inside it, and that's what gives the sour taste. Same thing with lime, lemon, orange, musambi, all these kind of which called the sweet lime, right? all these kind of fruits are called citrus fruits, and why they're called citrus is because they have citric acid, and the citric acid is what which gives the sour taste to that fruit. Then tamarind, right? Tamarind is another very popular popular fruit which gets added inside many curries that is made in India, right? And it also has a sour taste. And why does tamarind have a sour taste? And the reason why the tamarind has a sour taste is because it has got tartaric acid, right? So here you can see it. This is tamarind. It's very popular, and you can find it all over India, right? And you can find it all over India. So you can find it all over India, the tamarind. And you can see the tamarind tree where you have the tamarind which you can pluck, and some can have it raw, or you can actually add it in curries and all that, and gives that sour taste to the curry. And again, why the sour taste? Why is the tamarind having sour taste? Is because of the tartaric acid. And tartaric acid is what actually gives a sour taste to tamarind. So you can see the role that the acid is playing in your day-to-day life in terms of adding the sourness to all the curries and the pickles that you have. Then the ant sting, and as I told you, the ant sting is because of the formic acid, right? And the formic acid is what is injected by ant into your skin, and that gives the burning sensation. And that gives the burning sensation, right? And you feel like itching, and the burning sensation happens, and so on. And that's because of the formic acid. Then vinegar. Vinegar is again a very commonly used thing in Chinese preparations, right? And it's also used as a preservative. So if you want to preserve something, in olden days, people used to put that inside vinegar, and then it stays without much of a problem. And why is that, right? What is the reason why people put that in vinegar, right? What is the reason? And even the citric acid is used as a preservative. Preservative means the food item doesn't get spoiled. Now, what is spoiling all about? What is spoiling? Why do you say a food gets spoiled? Because of the decay, or it gets rotten, right? It gets rotten. And why does it get rotten? It gets rotten because of some kind of chemical change happening inside the fruit or the vegetable. And why is that chemical change happening? The chemical change is happening because of bacteria, right? So there are different kind of bacteria which is there in the atmosphere, and those bacteria can act on your vegetables or the fruits, and that bacteria can make chemical changes inside your fruit or vegetable, and that leads to rotting. So first there'll be ripening, and then there'll be rotting. It's decaying, right, of the vegetable or the fruit. And so this process of rotting of the vegetable or the fruit is because of the bacteria, and these bacteria cannot survive in an acidic environment, right? So if there is a lot of acid, and if you're putting a fruit inside an acidic solution like vinegar, now of course it should be acidic solution which is not poisonous or which cannot cause problem for our body, right? If I put that in hydrochloric acid or sulfuric acid, and then if I take that inside, then definitely it's going to cause a lot of problems, right? So vinegar is a mild acid, and it is used as preservative. Same thing with citric acid. And the reason why it's preservative is because the bacteria cannot survive in an acidic solution, right? And that's the reason. Now, definitely I will talk about it further when you move forward, but I'm just giving you some interesting fact of. So we are going to uncover a lot of interesting facts as we go forward, right? So you please wait. Now, vinegar, which is nothing but acetic acid, right? We're going to see the chemical formula of some of these acids like acetic acid and so on as we go forward, right? So you don't worry about that. We'll look at that. Then tea. Now, if you compare between tea and coffee, tea definitely has a little more sourness than coffee. I don't know whether you have I'm sure a large amount of people would have tried tea at some point of time. So I'm sure you guys and gals would have tried tea sometime in your life, I'm sure. And you might have also tried coffee sometime in your life. I'm sure that there are some of them who would not have tried neither. They might be the booze babies or the Horlicks babies, I'm sure. Right? But I'm sure there could be a large amount of people who would have tried tea or coffee. Right? Now, if you compare between tea and coffee, the tea is more sour, and the reason why it's more sour is because of the tannic acid which is inside which is there inside the tea. So you can see there are so many common. So buttermilk, curd, orange, lime, tamarind, vinegar. All these are things which you would have come across many times in your life, and all these have acids inside them. And that is what is giving them that sour taste. Alright. Now, why are these acids acids? What is the reason why these acids are acids? Right? The acids are acids because, when they dissolve in water, they actually ionize, and they kind of get split into the hydrogen ion, which is basically the cation, and some anion that depends upon the acid, right? So if you look at this, the hydrochloric acid, so this is the hydrochloric acid. So if you look at hydrochloric acid, you can see that it's got the H plus ion, and the anion is the chlorine ion, right? Because HCl, the hydrochloric acid is HCl, and so when it dissolves, it's going to actually dissociate into the positive hydrogen ion and the negative chlorine ion. Right? Now similarly, if you look at nitric acid, this is HNO3 is nitric acid. And nitric acid, when it is dissolved in water, it dissociates into the hydrogen ion and the nitrate ion, NO3 minus. It's a polyatomic ion. I'm sure that you remember that, right? We had discussed about polyatomic ions, and we in fact had discussed about nitrate ions there, which is actually anion, which is composed of atoms from different elements, and it has got one minus charge, right? And the hydrogen ion has one positive charge. So it actually splits itself. Once it dissolves into water, it splits itself into hydrogen ions and nitrate ions. So similarly, sulfuric acid, H2SO4 is sulfuric acid, which actually gets split again into two hydrogens. So one molecule of H2SO4, which is one molecule of sulfuric acid, gets split into two ions of hydrogen and one sulfate ion, right? And this is phosphoric acid, H3PO4, which gets split. One molecule gets split into three hydrogen ions and one phosphate ion. Right? And the phosphate ion has three negative charges, whereas sulfate ion has two negative charges. And all these is something which we have already seen, right? So we have looked at so we have actually looked at polyatomic ions with single charge, polyatomic ions with two charges, and polyatomic ions with three charges, right? So, and this is acetic acid. And if you look at acetic acid, it gets split into the acetate ion, so CH3COO minus, it's acetate ion, and H plus, which is the hydrogen ion. So what really happens is when any acid gets dissolved into water, it actually splits itself. The molecule starts dissociating into or splitting into the hydrogen ion and the corresponding anion. That depends upon what kind of acid it is. But definitely the acid will produce a huge number of hydrogen ions because it ionizes, or it splits itself into the hydrogen ion and the specific anion, right? So that is a very key point of acid. So that is the specific characteristic of acid. When it dissolves in water, it actually produces hydrogen ions inside because it actually ionizes and it splits itself, its molecule splits into the hydrogen ion and the corresponding anion. right? Now, typically what happens is that this hydrogen ion then combines with the water molecules, and that leads to formation of what you call hydronium ions. So in fact, once if you are dissolving some hydrochloric acid or nitric acid or sulfuric acid or phosphoric acid or acetic acid in water, what happens is that you can find that the molecules first split into hydrogen ion, the corresponding anion, and then this hydrogen ions will then attach itself to the water molecules, and because of that you will get the hydronium ion. Why? Because there is that hydrogen ion which is attaching to the water molecule has got one positive charge, and so that remains, and because of that you will have hydronium ions inside the acid solution. I hope this is very clear, right? Probably I can also kind of write this down. So let us take an example, right? So here is an example which I'm taking, right? So let me clear this page, right? So now let us say that I have hydrochloric acid, HCl, right? Now when it is dissolved in water, so I am dissolving it in water. What happens is that this gets split into hydrogen ion, H plus, right, and chlorine minus, right? Now these hydrogen ions are there. Now what this hydrogen ion will do is it will attach itself into a water molecule. So every hydrogen ion attaches itself to a water molecule. So what happens is that it becomes H plus plus a water molecule, it leading to H3O plus, and this is nothing but the hydronium ion. Hydronium ion. Now let me give you another point here, right? If you take distilled water is pure water which doesn't have anything inside it. Do you know that the distilled water is not a conductor of electricity? Pure water is not a conductor of electricity. That means electricity cannot pass through it. But why do you get shock from water? Right? The reason why you get shock from water is that means the electricity is able to pass through it. But water itself is not a good conductor of electricity. It just can't conduct. But why is it able to? Now, for example, assume that I dissolve water, a hydrochloric acid in water. Then what happens is it starts having ions inside it. And as soon as there are ions inside water, the water can conduct. Now, how it can conduct requires you to learn electricity. I'm sorry, you have to wait for that to happen, right? But what I want to tell you is why water is able to conduct is because if there are impurities inside water which can form ions inside water, then water can conduct. It could be, for example, traces of an acid, or it could be traces of a base, or it could be traces of certain salts which can ionize, because of which water has ions inside it, and as soon as water has ions inside it, it can start conducting electricity. So pure water cannot conduct electricity. It's a very, very bad conductor of electricity. But as soon as water becomes impure, where there's some traces of acid or traces of base or traces of salts which could be there, then they can ionize, and as soon as there are ions inside water, water becomes a very good conductor of electricity. Another secret that you've learned, right? All right, fine. So let us continue with the fun of acids. Okay, so that is about what really happens when the acid dissolves in water. We have figured out that it ionizes, and all acids produces hydrogen ions, and the hydrogen ions attaches itself with the water molecules and forms the positively charged hydronium ions. All right, fine. Now let us go ahead and now what is the base? What do you mean by bases? So The acids, when they dissolve in water, forms the positively charged hydrogen ions, whereas the bases, when they dissolve in water, forms what you call the hydroxyl ions, the OH minus, right? OH minus again is a polyatomic ion, and it's called the hydroxyl ions, and these kind of bases will dissolve in water and form the negatively charged hydroxyl ions, the OH minus. So that's a very high level difference between the acid and the base. Acid forms the H plus ions inside water when it's dissolved in water, whereas the bases, when they're dissolved in water, forms the OH minus, the hydroxyl ions. Did you understand that? That's a very key and very characteristic difference between the acid and the base. The acid, when dissolves in water, forms the the positively charged hydrogen ions, which of course can attach with the water molecules to form the hydronium ions, and when the base dissolves in water, it forms the OH minus, the negatively charged hydroxyl ions, right? So that's a very key difference between the acid and the base. So as we've seen the examples in acids, so we have HCl, the hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, acetic acid, and all that. Similarly, the examples for bases, of course, it's not necessary that all bases have the OH. It's not necessary. Of course, I've given examples here, but there are certain oxides, carbonates, which could also become bases, right? So we'll look at that later on. Don't worry about it. This is just a very high level first introduction to what are bases. We are going to deep dive into base and see a lot of characteristics and a lot of examples of what these bases are, right? So if you look at the base, these are some of the examples. NaOH is sodium hydroxide, right? MgOH2 is magnesium hydroxide, and CuOH2 is cupric or copper hydroxide. Cupric hydroxide also we can call, because now let us get into the valency, right? So what is the valency of copper here, right? And what is the valency? Just a small quick revision, right? So let us just do a small quick revision of valency, right? So let me clear this. So we are saying magnesium hydroxide is MgOH2, which basically means you have two OH hydroxyl ions, right? You have two hydroxyl ions, and only one magnesium ion. And of course, if it is only one magnesium ion, since all the molecule, complete molecule should be electrically neutral, it definitely needs two positive charges, right? Or that is basically, that means the magnesium should have a valency of 2, right? Because the magnesium atom should be contributing one electron to the hydroxyl ion and one electron to this hydroxyl ion, so that it gets the negative charge, right? So the valency here is 2. You agree with me? Absolutely, right? Now let us look at the copper hydroxide. Again, the same thing works out there too. Copper hydroxide is OH2, which again means that it should be Cu2 plus, and then you have OH minus and OH minus, right? So the copper should be able to contribute one electron to this hydroxyl ion and one electron to this hydroxyl, so that you have, both of them have one single negative charge, and then you basically have the copper ion having two positive charges. So which basically means here the copper has a valency of 2, and which means this is cupric, right? I told you that copper in the elements and compounds discussion, I told that copper is multivalent, so it can, in certain situations it can show a valency of 2, and in certain situations it can show a valency of 1. So, but here it has shown a valency of 2 because it is combining with two different hydroxyl ions. That means it has to contribute 2 electrons and from one single atom, which means that the copper's valency here is 2, and so this is cupric, right, and not cuprous. Because if it was cuprous, it would have been CuOH, because it can only contribute 1 electron. Alright, some small revision. Now, what is a salt? Right? Salts are compounds which are formed when an acid combines with a base. When an acid combines with the base, for example, let us take a simple example here. So I'm writing a small chemical reaction. So NaOH plus HCl gives NaCl plus H2O. Now this is a reaction where a base is combining with an acid to form a salt and water, right? And so this is actually a salt. So an acid combining with the base, it actually produces a salt. This is also called neutralization, and we'll see what is neutralization later on. I'm going to definitely go detailed into what is neutralization later on. Don't worry about it. I'm just introducing a new term to you. This reaction is also called neutralization, right? So the salt is always formed when an acid combines with a base. So when an acid reacts with the base, that leads to formation of a salt. So the reaction which I showed here, when a sodium hydroxide combines with hydrochloric acid, right? So the sodium hydroxide, which is a base, combines with hydrochloric acid, which is an acid, to form sodium chloride, which in fact is a salt. And this is nothing but the common salt that we use for curry, which is nothing but sodium chloride, right? So what you use in the curry, right? The salt that you use, that's nothing but sodium chloride. But this salt has nothing to do with that salt, all right? So any chemical reaction where a base reacts with the acid, it forms a salt. So there are different salts. So sodium chloride is a salt. Similarly, you can see different other examples. Copper sulfate, CuSO4. So now, what is the valency? Every time, think about it. Think about the ions. Think about the valency, right? So if you look at copper sulfate, what is the valency of copper here? Sulfate has got 2 negative charges, sulfate ion, right? So which means a copper should have given 2 electrons, and which basically means a copper should have 2 positive charge. So it's Cu2 plus and SO4 2 minus. So which basically means the copper has shown a valency of 2, right? Potassium nitrate, KNO3. What is the valency of potassium here? NO3 is a polyatomic ion, and its charge is negative 1 charge, which means potassium should have given 1 electron, which basically means potassium's valency is 1. And so it's K1 plus and NO3 1 minus, right? So all these are salts: sodium chloride, copper sulfate, potassium nitrate, and I can just keep on naming any number of calcium carbonate, calcium bicarbonate, ferrous sulfide, ferric sulfide, copper chloride, magnesium chloride. So there are enough and more of them, right? So there are several salts, hundreds and thousands of them, which is there on this planet, right? So we'll actually look at them later on and get into more details. So what have we seen till now? So I've just given a very basic initial introduction to you on what is acid, bases, and salts, right? So that's what I've done. So I've told you what is the definition of acid, and I told you that when acid dissolves in water, it gives a sour taste, and when it dissolves in water, it gives H plus ions, which attaches to water molecules and forms the hydronium ions, which are positive. And in the case of base, when it dissolves in water, I told that it actually gives hydroxyl ions, and the bases are usually bitter, right? So bitter in taste and soapy in feeling. So if you touch the bases, they are soapy. Now let me tell you one thing. If you're touching an acid or a base, you are doing it with a big risk, because many of the acids and bases are extremely corrosive. Extremely, I'm telling you, extremely. You touch it, it can burn your skin like bad, right, where you have to be taken to the hospital. So never ever venture in touching acids and bases unless your teacher asks you to do it, because they know which are the one which we can touch, because there are acids which are not strong acids, they're weak acids. So even if you touch, it's okay. Like vinegar, for example, right? If you touch vinegar, it usually doesn't give a lot of problems, right? So please be careful about it. I'm just warning you about that. So that's and then we talked about salts. Very brief, high-level definition of what a salt is. When an acid combines with a base, then actually they form salts, right? Now, so that is about it. So that is actually about acid, bases, and salts. Now, how do you classify these acids, right? How do you classify these acids? Now, the acids can be classified or categorized different ways. One is you can categorize it based on the occurrence. Occurrence is it naturally occurring with, or are they organic acids which are inside plants and animals, right? Are they those kind of acids, or are they mineral acids which are available on the Earth's crust, right? They are not necessarily found within the plants and animals abundantly, but mostly seen on the Earth's surface or Earth's crust, right, or in the planet, not on the living organisms. Then based on the strength, there are strong acids, there are weak acids. Now we'll get into what do you mean by a strong acid and what do you mean by a weak acid soon. So let us just wait for, I know you say it straight away, you'll have an answer. Question, what do you mean by strong and what this guy is talking about? Yes, I'm going to give you an answer. Just wait, right? Basis of concentration. So there could be highly concentrated acid or less constant, dilute, as you call it, dilute acids. Where I will tell you what these things mean. Dilute acid, concentrated acid. Then what do they contain? For example, do they contain oxygen atoms? Do these acids contain oxygen atoms or not? Right? And based on that, there are certain differences in their behavior. Right? So what are the kind of elements which these acids contain? Based on that, you can categorize the acid. Then you can categorize it based on the basicity. Basicity is in fact in terms of how many hydrogen ions can one molecule or the acid give. That is what is basicity. So for example, hydrochloric acid, one molecule of HCl can give one ion of hydrogen. So which basically means it's a monobasic acid. Right? So we'll actually look at some examples and compare what is monobasic, what is dibasic, and what is tribasic, and so on. So these are the various classifications, and we are going to kind of see these classifications now and where is what, right? So now I basically am trying to explain the based on occurrence, right? So you have organic acids is obtained from plants and animals. So they are actually existing in plants and animals. So some of the, I've already told, citric acid, lactic acid, right? Tartaric acid, tannic acid. All these are examples of acids which are, so the tartaric acid I think was in tamarind, right? And tannic acid is there in the tea. Then citric acid is there in orange, lemon, lime, and all those citrus fruits, right? Formic acid is there in the bee sting, right? And then now you're seeing another acid, ascorbic acid. Ascorbic acid is nothing but the vitamin C. Very important for our body to have vitamin C. And I'm sure in 6th standard you have learned what will lead to the if you have vitamin C deficiency, what kind of diseases can you have? There are several diseases. It actually reduces. If you have a vitamin C deficiency, then your resistance to these diseases will be very low, and you basically can become sick. So ascorbic acid, which typically comes from citrus fruits like lemon and orange and all that, is extremely important for our body to remain healthy. Folic acid. Folic acid is in fact very important for our hair, right? So folic acid is a very important acid which is important for our body. And folic acid is in lettuce. I don't know if you have seen lettuce. Lettuce is something like a leaf, right? And it's usually used in green salads and also for sandwiches and so on. Pretty big, light green colored leaf, which is pretty crispy when you eat fresh, right? And pretty tasty too, right? So if you get a chance to eat lettuce, just try it. I think it's a little bit expensive, so I've also not had a lot of lettuce because it's a pretty expensive vegetable to have. But yeah, if you get a chance, try it out. But one thing is, it's got folic acid, which helps your hair to grow. Formic acid. I spoke about formic acid in the bee sting and ant sting. Then oleic acid. It's there in olive oil, and oleic acid is also there in soaps. The soap that you apply, right? It has got oleic acid and also oleate, which are salts which can be formed from oleic acid, right? So the soaps that you use in the bathroom, right, has got both oleic acid and also can have palmitic acid. Palmitic acid is in palm oil, oleic acid in olive oil. Olive is in fact a kind of a seed, right, which can be dried and it can be pressed to extract oil. And olive oil is very commonly used in European cooking. So Italians and French and the Spanish people use olive oil quite a lot. In fact, we don't use it because olive is not something which is commonly available in India, right? So we use, of course, we use palmitic acid, we use coconut oil, and we use groundnut oil, and we use sunflower oil, and so on. We also use, I think, the gingerly oil, right? So, and mustard oil. So all these are things which are available in India, and so that's what we use, right? But olive oil has a lot of oleic acid. Palm oil. Palm oil, again, it's coming from the palm tree. The fruit which comes from palm tree can be dried and pressed to get the the palm oil, which has got a lot of palmitic acid. And the tea, as I told you, is got the tannic acid. So all these are examples of natural the acids which are available within certain fruits, vegetables, and so on. Right? Now, what about inorganic acids? Inorganic acids, or what is also called the mineral acids, right, which are available on the Earth's crust, which you don't really find directly, abundantly in plants and animals, and they are actually called the mineral acids or the inorganic acids. And example is hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. All these are examples of all these are examples of mineral acids or inorganic acids, which are not found in plants and animals. In fact, you can find some of these acids inside our body. For example, the stomach produces hydrochloric acid, because hydrochloric acid is important for digestion, right? So, because digestion needs certain pH values maintained. Now, then the question will be, what is this guy talking about? pH? Then I'll say pH is nothing but potence hydrogen. Then you'll ask, what is potence hydrogen? Yes, you need to wait. We're going to discuss about what is pH, what is importance, and what is acidic pH, basic pH. We're going to look at all that in the course of time. So don't worry, we are going to delve with that specific aspect soon, right? Basis of strength. Now, there are strong acids, there are weak acids. Strong acids are acids where it completely ionizes when it's dissolved into water, which basically means that once it is put in water, the water will be heavily concentrated with the hydrogen H plus ions, because it completely ionizes. Every molecule of the acid splits into hydrogen ions and the corresponding anion. And the example is hydrochloric acid and sulfuric acid. They are very strong acids, and they completely ionizes when they are dissolved into water. And every molecule of HCl and every molecule of H2SO4 inside the water will get split into the ions. So HCl will become H plus and Cl minus. SO4 becomes 2H plus and SO4 2 minus, right? So it ionizes completely, splits itself, and the ionic bond kind of breaks, and these ions will be moving around inside the water, and so it completely ionizes, right? What about the weak acids? So if you look at phosphoric acid and acetic acid, carbonic acid, H2SO3 is carbonic acid, right? All these are weak acids because they only partially ionizes. Many molecules remain as is, they don't ionize. Some molecules ionize. Maybe 20 to 30% of the molecules will ionize, but remaining. So if you look at H3PO4, how does it ionize? It becomes 3H plus PO4 3 minus. Right? If you look at acetic acid, CH3COOH becomes H plus and CH3COOH minus, which is acetate ion, right? And it's actually an organic compound. Now that is something which you learn probably in 9th standard. We'll start talking about organic chemistry, right? And at that point of time, you will actually learn about acetic acid, right? And then H2CO3. H2CO3 is a carbonic acid, and how does it ionize? It becomes 2H plus and CO3 2 minus. Right? Now, all these three acids, the examples which I've shown, they are weak acids and they don't ionize completely. Most of the molecules remain as is. They don't. The ionic bonds don't break, and they just remain as a molecule. Maybe a small portion, maybe 20 to 30% of the molecules will get ionized. So if you look at, if you dissolve same quantity of HCl, and maybe let us say 5 grams of HCl and 5 grams of H3PO4 in water, the number of hydrogen ions which you will find in the case of HCl versus the number of hydrogen ions that you will find in the case of phosphoric acid, you'll find that HCl will have far more hydrogen ions because it completely ionizes, where H3PO4, the phosphoric acid, the ionization is only partial, and so it will have far more lesser number of hydrogen ions. So that is basically the notion of strong acid and weak acid. So please understand that. Strong acid means it completely ionizes. Weak acid means it only partially ionizes in water. Now, what about concentration? Based on concentration. Concentration is how much acid is there per unit volume of water. If I take 1 liter of water, how many grams of the acid is there? More grams of acid is there in 1 liter of the solution, more concentrated it is, right? So that means if you say that this is a concentrated acid, well, that means that per liter of the acid there is a lot more chemical inside, dissolved inside water, right? Whereas dilute acid means per liter of the acid, the amount of the chemical dissolved is far lesser. So per unit volume of water, how much acid is present? That is what basically is a measure to look at the how concentrated the acid is, right? So per unit volume, 1 liter of water, does it have lot of acid or let it have only little acid? If it is only very little acid inside per liter of water, means it is dilute, right? And if it is lot of water, so you say milligrams per liter, or milligrams per milliliter, or grams per liter, or grams per you can say grams per liter, yes. So typically that's a unit in which we say. So this many grams of acid per liter. Higher that value, more concentrated it is. Lower the value, more diluted it is, or less concentrated. Dilute means less concentrated, right? So that is about the concentration. Then you have, based on the elements, there are different types of acids. Oxyacids. Oxyacids. The examples of oxyacids. Let me just write them. So the oxyacids are acids which have in fact got oxygen atoms inside them. So all these are examples. So H2SO4 is an oxyacid. H3PO4 is an oxyacid. HNO3. What is this? This sulfuric acid This is phosphoric acid and this is nitric acid. All of them have oxygen atoms inside their molecule. And if they have oxygen atoms in their molecule, so you can see oxygen here, then it is called the oxy acid. And those acids which doesn't have, which has only hydrogen. So of course, it'll oxygen atoms and hydrogen atoms. Of course, hydrogen atom is a must, right, for an acid. So any acid will have hydrogen atom, right? So, and if plus it also has oxygen atom, it becomes oxy acid. Whereas if it only has hydrogen atoms like HCl, it doesn't have oxygen, it only has hydrogen. HCl, HBr, which is bromic acid, iodic acid, HI, right? HCl. All these are examples of hydracids. Hydracids, which basically only has a hydrogen atom and doesn't have oxygen atoms, right? So that is basically about oxy acids and hydracids, right? Pretty simple. And the next classification is on the basicity. As I told you in the beginning, the basicity is based on how many hydrogen ions can be furnished or contributed or produced by one molecule of the acid. Right? So if you look at all these are monobasic, because why? When they are ionized, if you look at HCl, it can only produce one molecule can produce one hydrogen ion. The same thing with acetic acid. Same thing with nitric acid. All of them, one molecule can only produce one ion of hydrogen. Whereas this is dibasic because one molecule of sulfuric acid can produce 2 ions of hydrogen. One molecule of carbonic acid can produce 2 ions of hydrogen. So it's a dibasic acid. Whereas if you look at phosphoric acid, it's tribasic. Why? Because one molecule of the phosphoric acid can produce 3 ions of hydrogen. So the basic idea of basicity is nothing but the basicity is a measure of number of ions, hydrogen ions, which can be produced by one molecule of that acid when it is dissolved in water, right? So we have seen monobasic acids, dibasic acids, and tribasic acids. So